Next up, with his Hercules plane. This again, he's got plenty of props today. We have Rhys. So, can we have a warm round of applause, please, for Rhys?
Thank you very much, ladies and gentlemen. Tonight I want to talk to you about something that I do all the time: modelling. Now, clearly not fashion modelling. You can tell that from the way I stand in front of you, but numerical modelling, mathematical modelling, computational modelling. All engineers, or all fields of engineering, rely on models on a day-to-day basis. But why do we need models? Well, there are several reasons. I'm going to talk you through just a few of them in this short time. These days, budgets are tight, competition is high, and time is of the essence in projects. If you have a problem that you're trying to solve, and that's what engineering is all about, solving problems, and you have 5 potential solutions, but you only have the time or the budget to test 3 of them, modelling all 5 can be a very quick, easy, and efficient way of down-selecting which 3 you may be able to test. But sometimes we need to combine modelling with testing after the result. You've done some testing, you've got the results back, they've not come out as you expected. Using models, you can then model the same test setup, compare the results, and if the results match up, you have more confidence in those results. If they don't match up, then you need to ask why they don't match up. That could be a problem in the test setup, or it could be that you can't account for something in your model. Sometimes we have to model things because we actually can't test them. In the 1950s, a man called Tibor Hogarth invented something called the rolling sphere method for lightning protection. It involves taking the object you're trying to protect against lightning strikes, rolling a giant sphere across the surface, and wherever the sphere can touch is likely to be hit by lightning. Any areas it can't touch, such as the gaps between those winglets there where the ball just can't get in there, that's safe from lightning strikes. But we can't roll giant spheres over every aeroplane, so we have to model it. Now, sometimes engineers forget that their models are just models. 2 months ago at a conference in Vienna, the inventor of that method, Tibor Hogarth, got up and spoke to us as the lightning protection engineering community and told us that we were relying on his model too much. Because actually, if you think about it, if you roll this over the entire surface of the plane, the underneath of the plane appears to be very susceptible to lightning strikes. But when lightning strikes are coming down from the cloud, they're going to hit the top of the plane, not the underneath of the plane. It's a piece of information that the model doesn't take into account. Just like fashion modelling and clothes modelling makes assumptions about the bodies that those clothes are going to be worn by, engineering models make assumptions too. And engineers have to remember those assumptions and take them into account, because if they don't, when they start to use the results from those models, they'll start to become meaningless.